For this training session, we'll be going over the fundamentals of Boolean algebra. Now, what is Boolean algebra? Officially, Boolean algebra is a mathematical methodology which a base 2 output is generated by base 2 formulas and logic gates. In short, Boolean algebra is using addition and multiplication to solve binary equations. To reinforce a strong foundation of Boolean algebra, we must understand the fundamentals of the rules of Boolean algebra. In the shaded area to your right, you'll see 12 rules listed. These rules can be found in most common digital textbooks or any of your PE review books. We're going to be referring to these rules in the next examples so you can actually get a firm grasp and understanding of how they're used and the best ways to use them. Alright, let's go ahead and do a small refresher to knock off some rust that's gathered over the past couple of years before we get into the bigger problems. For starters, we're going to start with an AND gate. And with an AND gate, for these, there are going to be two inputs, A and B, with one single output. And since it's an AND gate, it's going to be A times B. And for our next most common gate, we're going to have an OR gate, which is slightly curved at the beginning there. That's going to be the two differences between my gates. You're going to see a slight curve for the OR gates and a flat starter with the AND gates. In other words, it's going to look like a D. Alright, and same different verse, we're going to have two inputs, A, B, and one single output, A plus B. When we work these problems, we're going to start from the inputs and work our way to the output to create one single output. For this problem, we're going to use three AND gates. Let's see if I successfully draw them. And we're going to draw our third. Please excuse the bad handwriting in advance. Now, this is just a practice problem to give you an idea how we're going to lay out some of these problems as far as finding the output with several visual gates. So, for this first AND gate, we have A times B. For the second AND gate, we have C times D. And when you have A times B and C and D on your third AND gate, it's going to give you an output of A times B times C times D. For this next problem, let's go ahead and mix and match the two gates. We're going to go ahead and use two OR gates, and then we're going to use, to combine those two, one AND gate. And this will actually make our output look a little bit more uncommon compared to what we just previously looked at. And as well as our inputs, let's not do the common A, B, C, D. Let's go ahead and have A naught, B, and then AB. Alright, same routine as the previous problem. Let's go ahead and work our way down. Let's go ahead and do our first AND gate, or excuse me, OR gate. So we're going to do A plus B, A plus B, and we'll do the second OR gate as well. So this one's going to be A naught plus B, and then we have an AND gate, so we're going to have to multiply these two together. So let's go ahead and bring down the first OR gate, so it's going to be A plus B, and since they're multiplied, let's go ahead and add our parentheses, and then the second OR gate is going to be A naught plus B. Now, looking at this problem, this is the actual output. However, it is not simplified. On the next problem, we're going to use our Boolean algebra and our rules to simplify the problem down to its final output. Let's see if we can finish this equation from the previous problem. So I want to multiply the left side times the right side. So this will give us the equation of A times A naught plus A times B. So it's going to be A times B plus, and then we have B times A naught. I'm going to say A naught times B. We're going to keep this in alphabetical order just to keep it simple. And then B times B.
Pretty simple. Now we're going to use our rules to the right to see if we could simplify this problem down just a little bit more. So if we look to the right here, a times a naught, let's see if we can find something to the right that looks similar to this. A times a naught. That's pretty easy. So when you bring this one down, that gives us 0 plus ab plus a naught b plus, well, we have b times b. Well, looking at rule 7, a times a equals a, so this would come out to be b. And I think we can work this down just a little bit more. So, looking at a plus, or I'm sorry, 0 plus ab, well, anytime you have a plus 0 is going to be that particular answer, so you can kind of negate the 0 there. So that would give us ab plus a naught b plus b. Let's go ahead and rewrite this. So it's going to be a b plus a naught b plus b. Let's go ahead and remove b out of all these equations, see what happens. So it's going to be a plus a naught plus 1. Because if you actually multiplied b times 1 would be your plus b. Well, let's actually look at rule number 2 up here. A plus 1 equals 1. So anytime you have an OR gate with a 1, which this would be considered a 3-input OR gate, that would actually give you the number 1. So that would come out to be b times 1. So that would give us a final answer of b. Well, it was pretty easy. Let's go ahead and do one more problem. Let's go ahead and make 2 OR gates. At least I'm going to try to. One day my handwriting will get better. And let's do 1 AND gate. Alright. Now for these inputs we're going to switch it up just a little bit. For this one we're going to say, let's try A, B, and then we'll try AC. Alright. Using our method from left to right, we're going to go ahead and see if we can get a final equation out of this bad boy. So we got A plus B, and then we'll go ahead and do the same for this one. A plus C, and this is going to an AND gate, so this would give us a final answer of A plus B times A plus C. Alright, now I can do the same thing I did in the previous problem and multiply both sides and get a long equation and work it down, or we can actually maybe get fortunate and take a look at our rule over here. Look at rule number 12. That actually mimics rule number 12 to the T. So this final answer will come out to be A plus B, C. Final answer. Alright, I think that's enough to get our feet wet. Let's go ahead and go to the De Morgan's theorem and see if we can really get some tough ones.